parameter means, say, efficiency, and then say load characteristics, torque speed characteristics, like that. Yeah. So I think you have already passed your machine 3 course, in which you had 2 and 3, machine 2 and 3, rigorous study on induction machine. So is it okay, na? 2 and 3 is completed for you, machine 2 and machine 3. I think in third year.
Ye- Yes, sir.
Hmm. So now the book, firstly we will suggest the two books. One is actually Indian author book, which is mostly followed, but with some risk of having some mistakes inside. Maybe you can yourself get, I mean, understand where is the mistake. But if you feel, then I can also help you. Some small mistakes inside are there. That is A.K. Sahani, that book, A.K. Sahani, Machine Design by A.K. Sahani, right? Machine Design by A.K. Sahani. And the other one, which is actually a very good book, which is followed as textbook or as reference book for machine other courses. That is MGSE, Performance and Design of Electrical Machines. I think alternating current machines by MGSE. There you find a lot of things design. I mean, almost all the machines design parameters and how to design formulas and all. Everything is there, and with a bit of depth. Although you won't find too many examples like what you will have in A.K. Sahani book. A.K. Sahani book is actually a student oriented book, which gives you a lot of examples for each of the machines you see. Like say three-phase induction machine, you will get at least example of 5 or 6 machines, different ratings they are designed, and from there you can actually have some idea and then design it. Okay. So now actually in remote mode, I don't have the notes here, but I can help you to, I mean, get to the formulas. So let's see how we can. We thought that this semester we can go with this offline mode, but still we are in same location as we had mm, last year. So first I will I mean make groups. I will give you each individual will get a design, maybe in a group, maybe 2 or 3 persons a group, a common problem, but I will request you to solve them independently. Okay, so that
Yeah.
all of you can learn. You can discuss yourselves, no problem. But it should not happen that one person does it and another person just copy it. This will only harm you, nothing else. You can get marks here, but in the long run you find, maybe you find or you may not find, because most of you or many of you will not be working in electrical area in future. Few of you, maybe 20%. Most of them are going to software jobs these days. I do not know, but still you have scope for to be within this electrical or electrical electronics design and then teaching, whatever it is. So my advice is that you don't go for copying. At least you should have some knowledge. When you face interviews, that you can answer there something. Okay. So then I am going to the display mode, where I will show you, give you the grouping first, and then after that, or grouping and the problem also. Uh, so is anything you are is displayed? Are you, is the screen you are getting your roll numbers only? The roll sheet. Are you
Yes.
able to see it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So then, as you are 34, so I will make say 10 problems on 9. So maybe 4 persons a group. Okay. So 4 persons a group, and then total 9 problems. Okay, maybe in the end you may get 4 3 4 3 like that. Huh? The initial group is 4, next group is 3 like that. I'll start and then we'll adjust later on. Okay. So Ankit Jaswal, you are present.
Yes, sir.
Ankit Kausik Maji, and then Swapnil.
Yes, sir.
Swapnil Kisku and
Yes, sir.
Deeptain. Okay, so all of you
Yes,
are
sir,
here.
present, sir.
Very good. All of you are here. So 02, 06, I'm writing here 09, 10, 9, 10. This. So you write down your own problem. Huh? Just I'm dictating. You can write. Huh? So you have to design a 3-phase induction machine. Let's say 110 volt line to line voltage. 110 volt line to line, 50 hertz, 50 hertz. And then the kilowatt rating is say 750 watt. And rated RPM is 735 RPM. 735 RPM. Right. So 3-phase, 110 volt, 50 hertz, 750 watt, 735 RPM. Efficiency you can assume, but power factor, also tentative power factor you can get tentative power factor of say 0.8, 0.8 tentative. It may not be. And temperature rise 40 degrees centigrade above ambient. So ambient you can say around say in India it is 40 degree average ambient. You can say that 40 degree. So 40 degree or 45 degree is above 40 degree ambient. So in the other problems, I will not indicate what is the ambient temperature. So you can actually get 40 degree as ambient as universal. Okay. Normally 25 degree is taken, but I mean in the current scenario, I think it is better to design for a little bit higher temperature. So this machine will be actually intended for say in small scale induction generator application. So we will see later on, but before that you should design it first. So 3-phase 110 volt, 50 hertz, 750 watt, 735 RPM, 0.8 power factor tentative, and you have 45 degree temperature rise above ambient. So now next group is Trina বিশ্বাস. Trina.
Yes, sir.
Present. And then Muhammad Ali Hanjan.
Yes, sir, present.
13, 15. Just a minute, someone has joined. So I allow him to come in. Muhammad Ali. Then Murmu Ala.
Yes, sir.
Alakar Janhi.
Present, sir.
What is your name? Alak
Sir,
Jarni.
Alak Jari
Murmu.
Murmu.
Aljani Murmu. So you are actually rule 17. So this group is of 3. Okay. All right. Or you need another one. More strength.
No problem.
Okay.
Sir.
No problem. So then your group will be actually a machine which is 3-phase. 3-phase, then say 230 volt, line to line. So all are line to line voltages. 50 hertz, 500 watt, 500 watt, same 736 RPM. After 0.8 and temperature rise 45 degree. Now I will give you another constraint, so that will be better. So the first
Sir,
group,
sir, excuse me, sir.
I will repeat it. Bolo.
Sir, what is 0.8?
Power
Sir,
factor,
you
power
said
factor.
0. Okay, sir. Okay.
0.8 power factor. Okay. Achha, now the first group, okay. The first group you design for minimum cost. First group actually, Ankit, Kausik, Maji, Swapnil and Ditain. So I have given you the problem. So you have to design the machine which gives you minimum cost. So one more constraint I am giving. Okay, and then this group, this Trinam, Muhammad Ali, Hamdan, and then Alk Journey. So you design for maximum efficiency. Got
Okay,
it?
sir.
So this machine will be designed for maximum efficiency. That means you have to do something so that at this maximum efficiency at rated load actually. Maximum efficiency means rated load. Minimum cost means minimum cost. Okay. Now next group is actually 18. Okay. Rajkumar, Rajkumar, 18. Present? नहीं. Mohammad Iqbal, 19. नहीं. अंकुश घोष, 20 नहीं. बाबा इधर क्यों नहीं? 21. मोहम्मद यूसुफ अली.
Yes, sir.
तुम आछो?
Sir.
You can convey this message. You can convey this message to your friend, to
Okay.
all these three friends, that the problem. So I'm giving you the problem, so you can note down and you can convey the message. So next week in the class we will see the progress or whatever you have done. That we will review. Okay, you can present from your end that, sir, this I have done. So then I can help you to do further, or some steps if you feel some problem, we'll discuss. So you design the same machine of the first group. Say this is three-phase induction machine, 3-phase 110 volt, 50 hertz, 750 watt, 735 rpm, power factor 0.8, tentative power factor. I'm always telling you it is tentative because it may not happen that you get the design at same power factor, but this is tentative. You can start with that. And temperature is same, 45 degree above ambient. You design for minimum weight. Minimum weight means the weight, machine weight for your design should be minimum. It will meet all the parameters, but you have minimum weight. And this first group, they will design the machine, everything, but their cost of the machine will be minimum. Okay. So this is what. Now,
Power factor table बोल
0.8 power factor universally for small machines. I am giving you 0.8.
Okay, sir.
Okay.
Okay.
Now the next group is Sheikh Arman Hussain, 22. Absent. 23 Sahin Akhtar.
Yes, sir.
Absent. You're there. Then 24 Parvez Musarraf Sheikh.
Yes,
Absent.
sir.
Achha, there. Okay.
Yes, sir.
Ritam Murmu, sorry, Khamaru, 26. Absent. So anyway, whoever is absent, you should convey this data. So you design a machine, say 3-phase, then 110 volt, 50 hertz, 500 watt. Now you go for you go for a little bit higher. So 415 volt will make 450, not 110 volt, 450 volt. Three phase, 415 volt, 50 hertz, 1500 watt. Okay, I'll give you a correction. Eh? Three phase, 415 volt, 50 hertz, 1500 watt, 1035 RPM. Then power factor 0.85. Tentative. Temperature rise 45 degree. And you design for minimum cost. You design for minimum cost. Okay. So you got it. So there are 4 groups we have made already. So how many students accommodated? 1, 4, 8, 12, 17. And then okay. Then another, that 1 group of 3 and 2 group of 4. That will be making total completed. So the next group is 27. Singh, 27 Dipankar Singh. Absent. Dipankar Singh, then okay. 29 Ghulam Mujadid Alam.
Yes, sir. I am present.
29, and then 13 1017 13 Sabuj Mondol.
Yes, sir.
Acha. Then 1002 Vikas Kumar Barnawal.
Present, sir.
Okay. Now your group, you design the same machine as the previous one, that is 3 phase, 415 volt, 50 hertz, 735 RPM, 0.85 power factor. But you design for 45 degree centigrade temperature rise, and you design for maximum efficiency. Maximum efficiency at rated condition. Huh?
Sir, could you
You
repeat
design for
once?
maximum
Sir,
efficiency.
will you repeat the parameter once again slowly?
Okay, 3 phase, 415 volt, 50 hertz, 1500 watt, 735 RPM, 0.85 power factor, 45 degree centigrade temperature rise, and for maximum efficiency. Okay.
Okay, sir, got it.
Achha, now next group, I'll make a group of 3. This group, Somnath Paul.
Yes, sir, Somnath.
Achha, then 04 Orijit Paul.
Yes, sir. Orijit.
And 05 Surojit Datto. Okay. Surojit. So then what you do, you design the same machine again. 3 phase, 415 volt, 50 hertz, 1500 RPM, sorry, 1500 watt. You make, I think, RPM, okay, let it be same. So we'll check the dimensions afterwards. 735 RPM, 0.85 power factor, 45 degree centigrade temperature rise. You design for minimum weight, right? So that your machine weight is minimum.
Sir, please could you repeat once again the data?
3 phase,
Yes, sir.
415 volt, 50 hertz. This is common.
Yes, sir.
1500 watt. That means 1.5 kilowatt. Huh?
Okay, sir.
735 RPM,
Okay.
0.85 power factor,
Yes.
45 degree centigrade temperature rise,
Yes, sir.
and designed for minimum weight.
Okay, sir. Thank you. So got it.
So 08 then. Subham Pariyar. Subham Pariyar. 10 Subhadeep Bera.
Yes, sir.
Then 15 Ujjwal Haldar.
Yes, sir.
And 30 Devar Godas.
Yes, sir.
Achha. So do one thing. So you take down the problem. So three phase, say 230 volt, 50 hertz, 1 kilowatt. 1 kilowatt. You take 9 say 65 970 RPM. 970 RPM. Or 970 you make it 960. 960 RPM. Okay. 960 RPM. 0.85 power factor. 45 degrees centigrade. Designed for minimum cost. Another problem. Next is 31. তাই তো? Hello?
Hello. Sir, the power
Hello?
factor was, the power factor was 0.8 or 0.85.
0.85.
Okay, sir. Thank you, sir.
85.
Yes, sir. Thank you.
31. Okay, next roll number. Subroto Mahata. Subroto Mahata. 31. Then 32. Arnab Pal.
Yes, sir.
34. Satyabrat Mondal. No, 36. Sheikh
Yes, sir.
Saik Rahman.
Yes, sir.
Acha. So you note down the problem. Three phase, 230 volt, 50 hertz, 1 kilowatt, 15 RPM, 1450 RPM, 1415. One is joining, just a minute. Huh. 1415 RPM, 0.85 power factor. Right, 45 degrees centigrade temperature rise, which is common. You design for minimum weight.
Okay, sir.
Okay. So then I think I am left with only one group. Huh? That is 37. Sheikh Mohammed
Yes, sir.
Sohail.
Yes, sir.
37. 38. Saudip Sen.
Yes, sir.
40. Salik Sahib. And then 41. Rejoin Sheikh. Like
Yes, sir.
Region Sheikh.
Yes, sir.
So just now you have joined. Acha. You take down the problem. Three phase, 230 volt, 50 hertz, say 1 kilowatt. You take 1 kilowatt, and you make the machine a lower speed. That is, say 730 RPM. 730. Okay. 0.85 power factor, 45 degrees centigrade, Designed for maximum efficiency. Designed for maximum efficiency at rated competition.
So what
So
is the
now
rating of the machine?
1 kilowatt, one.
Okay.
Power rating is 1 kilowatt. Huh?
Okay.
I'm repeating again. 3-phase, 230 volt, 50 hertz, 1 kilowatt, 730 RPM, 0.85 power factor, 45 degrees centigrade temperature rise above ambient, and you have to design for maximum efficiency.
Okay, sir.
Okay, sir.
That's all. So, in your book today, actually, I will give you the instructions. Actually, you should have at least one book with you. Eh? Among these two books I have told, it is better to have the first book at the initial instant, because in this book you will find a lot of problems are there, which will be helpful to solve your problem. You can see at least 3-4 problems and then start your own problem. The first step there you will find always to make the mean dimensions, to design or to have a gross estimation of the main dimensions. So what are the main dimensions? Actually, in a machine, you will find the main dimensions are rotating machine are length and diameter. Now, d square L, actually, this gives you an idea of volume. Okay, so normally you find that that larger machines have larger volumes. That means from there you can guess, actually, looking at the dimensions of the machine, you can guess that what could be the power rating of the machines. You cannot extract large power from a very small dimension machines. That is your own idea also. When you go to see different motors and see your laboratories and your in your domestic applications, fans and all, they are very small. So their power is small and their volume is also small. So first is to get the main dimensions. Okay. So I will expect that you just get an idea after reading the books that how to get the main dimensions in the next class. Because today I haven't prepared anything for you to give you. I mean that thing. I thought it will be there, but anyway, let's see actually how it can start. Maybe in a 1 or 2 week, if nothing is done, then we will go see that you solve the problem, and then I will be helping from this end, looking at your presentation. So one group you can present that I can we have done up to this, then next steps and all. Okay, so any questions you have?
Sir, main book which we will follow?
Both the books are important, I'm telling you. The first book, the A.K. Sahani book, I think will help you better to start initially. Okay. And if you get started, then you can consult any of the two books.
Okay, sir.
I mean, now the college is also closed. I don't know how many of you are having these books. Do you have any books with you? Try to find out. Huh? Okay. Hello?
Yes, sir.
Oh, I thought I lost connection. Anyway, so let's see actually how much you can progress in the next day. Depending on who will decide that how to progress with this class. Otherwise, I will allow some more time, that you take 2 weeks time, and then so. Then I will also give you some salient points, which points to check. And then how to assume the data. First of all, you have to read how they have done. at least one problem. And then depending on the machine sizes, some data also has to be adjusted.
Sir, you are not audible.
Sorry, but actually I lost the connection. Suddenly the connection has become unstable. So do one thing, then we will meet in the next class. So then I will be a little bit fitter also, and then you can tell me your problems of what are you facing. Okay. You try to calculate the main dimensions first. Right?
Yes,
Hello?
sir. Yes, sir.
Okay. Okay, so I think someone of you telephoned me. What is your name?
Sir,
Regarding
Ankit.
this class. Huh?
Ankit
Ankit,
Jas.
Acha,
Yes, sir.
Ankit, then I will just request you one thing, as you have sent so many things, that who are present today, I didn't note down. You can present in today's class and absent, if you can help me. Okay,
Okay, sir.
you can mark it and send. Okay, so I leave today now. Is it okay for you now, or you have more clarifications to ask?
No, sir, fine.
Okay, so I'm leaving now.